This is 8 Minutes, a podcast helping you understand the energy and climate challenge in just a few minutes. I'm your host, Paul Schuster. Nature-based solutions for carbon capture are not new. The Trillion Tree Project is just one example of how entities are looking to the Earth's natural resources to help us stave off climate change. And of course, we're developing mechanical solutions like direct air capture or point capture technologies to help that process along. What hasn't gotten a lot of attention is the role oceans play in carbon removal. Covering 70% of our planet's surface, the ocean today is already a huge carbon sink, but maybe we can leverage it to do even more. Today, I'll discuss the current role of the ocean in carbon removal and how some new innovations offer promising opportunities. 8 minutes. It's how long it takes the sun's rays to hit Earth. Or, well, when I was launching this podcast series, I wanted it to be something people could listen to during a workout or something, which led my wife to say that, given my workouts, we should probably keep the episodes to 8 minutes. Let's get it on. The ocean is a huge carbon sink. Per the World Resources Institute, the ocean currently holds about 42 times more carbon than the atmosphere. And if there was a safe, economical way to leverage that capacity, we could potentially remove billions of tons of CO2 every year. However, a lot of the work on carbon removal is focused on land-based solutions, either nature or mechanical-based, and ocean solutions have been underinvested. Increasingly, though, it looks like we're going to need every tool in the toolbox if we want to measurably alter the course of climate change. It may seem somewhat counterintuitive to think about the ocean absorbing carbon dioxide from the atmosphere, but believe it or not, CO2 actually does get dissolved into the saltwater. Think of it as a non-pressurized version of what happens with your favorite soda, where CO2 is dissolved into the liquid. These aren't smaller CO2 bubbles, but they are actually individual molecules of carbon dioxide that have a loose bond with the H2O molecules of water. For our sodas, that bond is super fragile, and the carbonated drink can go flat in just a few hours as the bonds break down. In the ocean, that carbon removal is more resilient, partially because of the water temperature, and also because the carbon that dissolves in the saltwater undergoes chemical changes. A CO2 molecule with an H2O molecule becomes H2CO3, also known as carbonic acid. But carbonic acid is inherently fragile, so it breaks apart to form ionized hydrogen atoms and bicarbonate atoms. You may have heard about the increasing acidification of the oceans. Well, that's because of those new hydrogen ions. And here's the thing. The more carbon we put into the atmosphere, the more carbon the ocean attempts to absorb. It's not a 1-to-1 ratio, but the Union of Concerned Scientists estimate that since the start of the Industrial Revolution, the ocean has absorbed about 29% of all emissions. Good for carbon, but bad for ocean acidity. And that means that any ocean-based solutions that we come up with need to balance this extreme potential for carbon removal with the need to avoid increasing the acidity levels of the ocean anymore. Those evolving removal solutions generally fall within 3 buckets: biological, chemical, and electrochemical. The first is biological removal, for instance, by cultivating seaweed, which is extremely efficient at photosynthesis and carbon removal, and then purposefully sinking the seaweed to the ocean's floor where it's effectively sequestered. Companies such as Running Tide and Seaweed Generation are actively exploring that option. A more controversial biologic solution involves fertilizing parts of the ocean with trace amounts of iron. The idea here is that the iron encourages phytoplankton growth, which in turn captures carbon from the atmosphere. The controversy is that it could also lead to toxic algae growth and oxygen depletion if managed poorly. A separate category of carbon removal relies on chemical solutions. In this case, finding ways to solidify the dissolved carbon in the water in order to sink the solids and keep them permanently on the ocean floor. For instance, Vesta has been experimenting with adding ground-up alkaline rock to seawater, which, when reacting with CO2, creates solid carbonates, which presumably sink down to where they are no longer a problem. The problem with this solution, well, any trace amounts of toxic minerals embedded within the alkaline rock mix could prove harmful to the fragile marine ecosystem, so it requires extremely careful handling of the minerals. The last category of removal that companies are considering is electrochemical, where electrolysis is used to break down the seawater into hydrogen and carbon. The hydrogen could possibly then be sold for industrial applications, and the carbon could be sequestered into long-term storage sites similar to those used for direct air capture or point source capture solutions. Companies like Captura, Aquatic, and CO2, C as in SCA, get it, are looking at these technologies. But of course, those solutions have issues as well, many of which are not only similar to other hydrogen processes, but also other carbon sequestration challenges as well. Whether it's a biologic, chemical, or electrochemical solution, addressing these challenges will require investment and innovation, which is something that ocean-based solutions haven't had a lot of in the past. That may be changing. For one thing, governments are beginning to fund initial research, development, and establishment of regulatory processes for ocean solutions. This includes the Department of Energy allocating $10 million for research and another $25 million as a carbon removal X Prize of sorts. The National Oceanic Partnership Program provided $24 million to 17 teams working on research, and private industry is stepping up with companies like Shopify, Microsoft, Boeing, and others providing at least $7 million in advanced market commitments to innovating companies in the space. Ocean-based carbon removal has a lot going for it, not just because of the enormous potential it has to scale carbon sequestration at economically reasonable prices, but in helping to reduce the acidity and viability of the broader marine ecosystem. Despite that, though, the investment into the space is still very limited. While industry focus has been on mechanical solutions or plant-based solutions on land, the potential for ocean-based removal has largely remained overlooked. Both public and private funding for this important space needs to improve so that we can truly assess whether ocean-based solutions are a viable alternative. I'm Paul Schuster, and this has been your 8 Minutes.